Hello, welcome to the How to Go Solar and Storage webinar. My name is Abigail Jager, and we're going to go ahead and get started. Thank you so much for being here today. Today, we're going to cover many aspects of solar and battery storage. We'll start by taking a look at how solar works. We'll see the components in a system, learn about a process called net metering that allows you to get credit for the energy bills you export to the electrical grid, and see how solar saves you money on your utility bills. Next, we'll take a look at how solar contractors assess your home. We'll see common issues that your site that can increase the cost of solar installation or that can prevent you from being able to go solar altogether. We'll then take a tour through the exciting and popular topic of energy storage and see how a battery can allow you to use power when the grid is down. After that, we'll learn about the incentives available for solar and battery storage, and we'll walk through several example budgets. We'll wrap up by talking about contractor selection and the installation process. We're here to get your questions answered, and after the main presentation, we'll have an extended Q&A session. Any and all questions about solar, battery storage, or even related technologies are welcome. This presentation is put on by Solar Oregon. Solar Oregon is a 501c3 nonprofit that has worked to encourage solar and storage adoption throughout Oregon since 1979, and it is the organization that employs me. I'm a program manager there. We do this by providing reliable and impartial consumer education like this workshop, working to build the clean energy community, improving outreach, and some policy advocacy. We also facilitate solar tours, zero energy showcases, expert panel discussions on a range of topics, and solarized campaigns, which are regionally focused short-term events where you can access solar discounts by going solar with your neighbors. You can learn more at our website at solaroregon.org. And I'm going to put a link to that into the chat, as well as some other resources that I'll be referencing throughout the presentation. I'm also going to go ahead and launch some polls. These are completely optional, but they just let us know some demographics about who's in the Zoom room with us today. There are going to be 3 polls in total. I'm going to launch at the beginning here, and if you wouldn't mind filling them out, that would be great. Thank you. I'm going to launch the next one, and then we'll go on to the next slide. This workshop is supported by Energy Trust of Oregon. Energy Trust is an independent nonprofit established in 2002 that provides resources to help enable customers of the investor-owned utilities throughout Oregon to use energy efficiently and gain access to renewable energy. They offer key incentives for solar installation and battery storage and coordinate a network of solar trade allies who are able to offer these incentives. We'll talk more about these solar trade allies later in the presentation, but want to thank Energy Trust for their continued support. For more information, you can visit energytrust.org, which is also linked in the chat. And thanks so much for filling out that poll. I have one last one I'm going to launch. And then we'll dive into how solar works. I also do want to mention that if at any point during the presentation you have any questions, feel free to put them into the Q&A section at the bottom of your screen. It should say Q&A on it. We'll be going through all the questions there at the end of the webinar. No need to wait until we get to the end to put your questions in. You can put them in at any time. Now, without further ado, let's look at how solar works. This is a diagram of a typical home solar system. You can see the house in the middle of the diagram and the photovoltaic or solar panel on the top left. Sunlight strikes the solar panels, labeled here as a photovoltaic panel, and produces a voltage of electricity. The voltage of electricity it produces is a special type of electricity called DC, or direct current electricity, which is different from the AC, or alternating current electricity used by the lights and appliances in your home. That's why it has to flow from the solar panel to a special device called an inverter or microinverter that converts the DC electricity produced by your panels into the usable AC electricity used by your home. From there, it then flows into your home electric panel, where it goes to power your lights, charge your computer, charge an electric vehicle, and do everything we need power for. If at any point in time your solar panels are generating more power than your home is using, any excess power you're generating flows out to the utility grid, where it is tracked by your new bidirectional utility meter, and it flows out to the utility grid to be used by your friends and neighbors. And similarly, if at any time you are not producing enough solar power to power your entire home, such as at night, then you are able to draw power from the utility grid to help cover that difference. We're going to be looking at next at some of these components in more depth. So first, let's take a look at the component that converts the DC electricity into the solar panels into the usable AC electricity for your home. There are two options available, inverters and microinverters. The white box in the image on the left is an inverter, sometimes called a string inverter. It accepts the electricity from all your solar panels and converts it all at once. So if you have 10 solar panels, you'd only have one inverter. The inverter is typically installed on the wall immediately next to your electrical panel, aka your breaker box. However, if space is not available near the breaker box, it can also be installed outside as it is pictured here. In this case, there may be extra costs due to longer conduit runs. The smaller black boxes pictured in the image on the right are microinverters. These are installed immediately beneath the solar panel. So, and when we're looking at this image, we can imagine we're looking up at some solar panels. And each microinverter takes in electricity from only one or two solar panels. So if you have a 10-panel solar system, you could have up to 10 microinverters. Both inverters and microinverters are great options that are installed frequently in Oregon. Your contractor may suggest one over the other based on the specific needs of your system. Now, in order to be ready for solar, your panel main breaker needs to be rated for at least 200 amps in most cases. Larger homes will require a larger breaker for solar, while some smaller homes may be able to manage with less amperage, but in general, we recommend at least 200. Common signs that you will need to replace your electrical panel before installing solar panels include your main breaker is rated for less than 200 amps. You plan to install solar and battery storage and/or an EV charger now or in the future. You plan to install more electrical appliances such as a heat pump or heat pump water heater, or if you plan to install a pool or hot tub either now or in the future. And if you're already experiencing issues with your current electric panel, such as tripped breakers or flickering lights, these could all be signs that it is a good idea to replace your electric panels before going solar. Now, solar panels can be mounted either on your roof or in a ground-mounted system. Roof-mounted systems account for the vast majority of solar installed on homes and businesses, especially in dense urban areas where ground space is not available. Ground-mounted systems can be a great option for families with more space. However, because they still need to be wired into your home's electrical panel, ground mounts installed far from the home can increase the total cost of your system. This cost is partially due to the high cost of copper wiring, as well as expenses related to burying the wire underground. So as mentioned earlier, when your solar system is producing excess electricity, it gets exported to the grid where it can be utilized by other utility customers. This is known as a grid-tied system, as you are still tied to the electric grid, as opposed to an off-grid system where you would have no support from the grid. Net metering is the process that allows you to account for the energy you export so you can gain credit for it and save some money. So I'm going to illustrate how this works by walking through two examples. The first, a typical sunny summer month, and the second, a typical cloudy winter month. So the graph on the left shows what's happening in a summer month. Kind of on a day like today, it's been pretty sunny all day, and I know here in Portland it was really sunny yesterday. So that orange bar shows us how much electricity we've produced over these last few very sunny days. And the blue bar shows how much electricity we've used with all our lights and appliances. Because we produced more than we've consumed, this is a month we're going to be exporting electricity. The green arrow shows the difference, which is your net metering credits earned. Now, if we think back like 6 months ago, it's dark, it's stormy, it's cloudy. We are not having 77 degrees days like we did today and yesterday. However, our solar panels would still produce some amount of electricity even during these cloudier months. So the graph on the right shows a typical winter month when you're using a similar amount of electricity but producing less with your solar. The red arrow shows the amount of electricity you'll need to purchase from the grid in order to make up that difference. With net metering, the credits you earn during the sunny summer months offset the electricity you purchase in the cloudy winter months. So in order to make this happen, your net metering credits do roll over from month to month. However, it's very important to note that does not roll over from year to year. The net metering year begins and ends right around March 30th, depending on where your billing cycle is at around then. This allows you to build up credits during the sunny months and then use them all winter. Any excess credits you have at the end of March 30th, when the net metering year ends, are donated to the grid to low-income customers, and you will not receive any excess credit or funds back for those credits you donate. So now I'm going to look at what this looks like in practice. So here's what your monthly electricity bill might look like when you are net metering with solar. This is an example from a PGE customer. So your bill might look a bit different if you are a Pacific Power customer, but we're going to walk through some of the details. In the box, you can see the period for which you are being billed, the reading on your bidirectional meter at the beginning of the month, and the reading at the end. Thanks to your new bidirectional meter, the electricity you import from the grid is recorded separately from that which you export. You can see the total amount of electricity coming into your home this month was negative 327 kilowatt hours or kWh. This means you exported more than you pulled from the grid and you have gained 327 kilowatt hours of credit that you can use later. Because you are a net exporter this month, your billable kilowatt hours is 0. You may be surprised to find that your bill, however, is not 0. This is because your utility connection comes with a base charge. This is what all the utility customers pay to maintain the grid. There are also taxes and fees that can increase your bill a few dollars. Compared with the average Oregon utility bill of about $100, this is still a great deal. This is an example of savings you'll receive on your electricity bill each month for the useful lifetime of your solar system. Compared to the rest of the country, the Pacific Northwest has cheap grid electricity due to our abundant and well-utilized hydroelectric dams. However, electricity prices still increase steadily at around 2 to 6% per year, and solar would not increase at the same rate. So again, while it is disappointing that you would not get a bill in the mail for $0.00, $12 to $18 is still much less than that average bill here in Oregon. Now, solar is a highly modular system, and residential solar systems vary widely in size. System size is measured in a unit called kilowatt or kW, but the average residential size in Oregon is 8 kilowatts. What determines your system size, by far the biggest constraint, is how much electricity you consume. This is because, as mentioned, net metering credits do not roll over from year to year. This means to get the most value out of your system, your contractor will want to design it to meet but not exceed your estimated annual consumption. Your contractor will ask you for past electrical bills to determine your future needs. If you're expecting to install appliances or make life changes that will significantly increase or decrease your expected consumption, make sure to let your contractor know. Examples include switching between gas and electric water heaters, purchasing an electric vehicle that you intend to charge at home, or having anyone move in or out of your home. Other factors that can limit your system size are available roof space, budget, or limitations placed by an HOA, condo association, or historic district. However, it is important to note that it is illegal in Oregon for HOAs to tell you can't go solar. They can impose restrictions on how you go solar, including preventing installation on the street-facing side of the home. If you have any further questions about that, or you're having issues with your HOA and you want to install solar, feel free to get in touch with us at info@solaroregon.org, and we're happy to do our best to help you. So now, with all this information, how can you know if your home is right for solar? Regardless of your location in the state, the orientation of your roof has a big impact on your solar access. Your solar access refers to how much sun your roof gets. This diagram shows a home and its orientation with respect to the cardinal directions. The arcs over the home show the path of the sun in the summer and the winter. Regardless of season, the sun will always be in the southern sky. This means that south-facing roofs are ideal for solar. However, both west and east-facing roofs can work great. In cloudier parts of the state, roofs facing due east can be slightly less effective, but you can talk to your solar contractor if you have concerns about that. The only roof planes that consistently don't get installed on are north, northwest, and northeast facing. Now, even if you have a perfectly south-facing roof, shade from objects like trees or nearby buildings can prevent you from receiving enough solar resource. However, it can be hard to self-assess whether shading your roof receives will negatively impact you. Your solar contractor will be able to better assess this for you with precision, either using a special measurement device or satellite-based software. And even if your home is very well shaded, you don't want to cut down all those beautiful trees. They do really great work helping keep our city cool. Instead, I'd highly encourage you to check out community solar, which is another great option that still allows you to support solar in our state. Now, one of the biggest factors that can affect whether you're able to go solar is your roof condition. Your roof will need to be replaced when it reaches the end of its lifetime, and when you do that, you'll need to pay a solar contractor to uninstall and reinstall your system. This service can cost over $10,000, so it's very important to plan ahead. For this reason, we strongly recommend that you have 10 plus years of roof life left when you install solar. Different roof types have different lifetimes, with metal roofs typically having a much longer lifespan than asphalt shingle. However, virtually all roof types can work well with solar. If you're expecting needing to re-roof in the next few years, you should wait until that time to install solar so that the roof life matches the life of the solar panels. The complexity of your roof can also impact your ability to go solar. Solar systems can be split into several sections and span multiple roof planes. However, the ideal roof will allow for a single continuous installation on one roof plane. Newer homes tend to have trusses. Sorry. And it does not just matter the shape of your roof and the condition of it, but what's under your roof also makes a difference. Newer homes tend to have trusses. These extra vertical and horizontal support beams meet even the strictest requirements for solar. Older homes tend to lack these extra support beams and might just have rafters extending from the eave to the crest of the roof. In this case, your home may still meet some stringent requirements, but based on the geometry of the attic, your contractor may need to hire an engineer to perform calculations for the permitting office. These extra costs occur particularly for older homes built pre-1950s in the Portland area, especially with urban craftsman architecture. In rare cases, your home may not be able to meet local code requirements, even with reinforcements. And you can also be prevented from going solar if your attic is inaccessible or if there's not enough roof for your contractor to perform the necessary reinforcements. Now, we're going to dive into the exciting topic of battery storage. It's important to know that your solar system by itself does not allow you to use your solar electricity during a power outage. To do this, you'll need to add a battery. The ability to use power when the grid is down is called energy resilience. Solar and battery storage are complementary technologies. Solar makes the battery more effective by recharging it, and your battery allows you to access your solar independently from the grid. Power outages can vary in their causes, their frequency, and their duration. Frequent short outages are usually caused by either storms or squirrels, and in some areas, slightly longer outages in the summer months can be caused by red flag weather conditions when there is a high fire danger. At these times, utilities may perform what is called a public safety power shutoff. This is where they intentionally turn off whole sections of their grid if they think their power line infrastructure could pose an unacceptable fire risk. In the Pacific Northwest, we also face a unique risk of a large earthquake, the Cascadia earthquake. When this event occurs, it's thought the power may be lost in the Willamette Valley for up to 6 weeks. On the coast or other rural parts of the state, power may not be restored for several months. It's important to know what type of outage you're expecting so that your contractor can design a system that will meet your needs. When choosing a battery, there are many quality options. However, because of manufacturer certifications, contractors often specialize in a specific brand. To compare battery technologies, you may need to get quotes from multiple contractors, which we recommend you do anyway. It's important to remember that you can't mix and match battery brands. So if you already have a Tesla Powerwall, you would not be able to add an Enphase battery. However, your solar panels and your battery do not need to be the same brand. And some manufacturers offer different modules that have limitations in how they can be further combined. Battery capacities are measured in kWh or kilowatt hours, and most batteries range from 10 to 14 kilowatt hours, with some smaller units in the 3 to 4 range, while there are some larger ones that go up to 20. In Oregon, the average battery size is 13.5 kilowatt hours. For standard household electric loads like lights and appliances, many batteries will perform well. If you're intending to use the battery to back up a load that requires a lot of instantaneous power like a motor, your contractor will need to factor this into the system design. If you're installing a battery, when you install it can also impact both the system design and the price. Put generally, there are two options: installing solar and battery at the same time or adding a battery to an existing solar system. You can get a battery without a paired solar system, but we don't see that happen quite as often. Why can the timing of battery installation affect the design of your solar system? Well, each system is designed in a custom way to best fit your needs, and the components are selected to match one another as closely as possible. This minimizes the cost to you and allows for the immense flexibility of solar. However, this flexibility during the initial design means that adding new components afterwards, like a battery, may require more parts and labor than if you had incorporated them during the initial design. Additionally, because batteries and solar panels operate under DC or direct current electricity, where your home uses AC, your contractor can choose a single inverter if the system is designed together, and adding a battery later may require a second inverter. Late additions may also lead to inefficiencies like space constraints, longer conduit runs, and extra labor. For these reasons, installing a battery after the fact can cost up to $10,000 more than incorporating it into the initial system design. And lastly, batteries need a dedicated space, ideally near the electric panel, often in the garage. If space is tight, they can go on an exterior wall. However, per fire code, batteries cannot be installed in a crawl space, cupboard, or other confined area. Now, it is very important to set your expectations properly about what a battery can do and what it cannot do. Even if you don't use much electricity, a single battery will almost never back up your entire home for any meaningful period of time. However, you can do what is called a partial home backup. In this scenario, certain circuits in your home will receive power from the battery, but the rest of your home will lose power during an outage. If you're able and willing to front the extra costs, multiple batteries can allow you to achieve a whole home backup. This process is prohibitively expensive for most consumers, but is a simpler and most efficient process overall. When you get a partial home backup, the way you divide your home into sections that are backed up and sections that are not is based on the breakers in your electrical panel. When you've selected which circuits you'd like to receive battery power, your contractor will remove those breakers and place them in a newly installed smaller essential loads panel. This second electric panel will be wired to the battery, and in the event of the outage, only the second electric panel will receive power while all your other circuits will be automatically turned off. There are also newer technologies like smart breakers or smart electric panels that can provide more customization and flexibility with the ability to move circuits between different categories via an app. If you have an older home, you may need to upgrade your electric panel anyway before you go solar, so looking into seeing if a smart option is right for you can be a good idea. The battery system sizing process will entail a detailed conversation with your contractor, balancing your desired functionality with your budget. A great way to think of this process is a trade-off between the two questions: what needs power and for how long? Items most frequently chosen to back up include a refrigerator to keep food from spoiling, lights in common areas, and a couple of outlets to be able to charge a laptop or cell phone. So now that I've gone through all the technologies included in your solar system, I'm going to take a look at incentives and financing. Energy Trust of Oregon offers a standard solar incentive that depends on the size of your system and your electric utility. Excuse me. For Portland General Electric customers, Energy Trust offers $2,500 for an installed solar system and $400 per kilowatt hour, up to $5,000 for installed storage. And for Pacific Power customers, they offer that same $2,500 for solar and $288 per kilowatt hour, up to $3,600 for storage. For installed storage. You can receive this incentive whether you install solar and storage at the same time or separately. In order to receive this incentive, you must have your system installed by an Energy Trust Trade Ally contractor, and the system must meet Energy Trust standards. If your utility is not PGE or Pacific Power, you unfortunately will not qualify for Energy Trust of Oregon incentives, but your utility provider might have other incentives available, so it's worth it to reach out to them to check. The availability of these incentives varies and are subject to funding availability and current policies. You should check with your provider to see what incentives are currently offered. I can only guarantee that these are correct for today. And so, like I mentioned, in order to receive this incentive, what you have to do is install your system with a Trade Ally, and luckily that's all you have to do. The Energy Trust Trade Ally will fill out all the necessary paperwork and ensure that your system meets Energy Trust standards. Now, beyond the standard incentive, Energy Trust also offers an income qualified incentive. Energy Trust of Oregon Solar Within Reach is a $1 per watt incentive that allows PGE and Pacific Power customers to reduce their solar and storage installation costs. For example, a household of 4 qualifies for Solar Within Reach if their annual income is under $128,564. You can find all the cutoffs listed on the Energy Trust website, which is listed in the chat, or by scanning the QR code on your screen. Because solar and battery storage entail large upfront costs, many homeowners utilize financing. Some homeowners obtain a loan through a bank with which they have an existing relationship, but some banks do not provide loan products specifically tailored to solar. Your contractor may partner with a credit union or third-party broker that offers a package that is geared towards solar. As with any major financial decision, make sure you carefully assess your financing options. Energy Trust of Oregon recently launched Smart E-Loans in partnership with Solar Trade Allies and Inclusive Prosperity Capital, a 501c3 clean energy financing platform. ETO Smart E-Loans can be used to install solar, solar plus battery storage paired with a qualifying solar system, an electric vehicle charger paired with a qualifying solar system, or enabling upgrades and repairs up to 25% of the loan amounts. Here are some of the benefits of the Smart E-Loans. Transparency of a clearly stated interest rate without any other hidden fees, no fee or prepayment penalties. It is an unsecured loan with no need for collateral. Low FICO credit scores as low as 580 are accepted, and flexible terms of 5, 7, 10, 12, and up to 20 years, and rates as low as 6.99% with a very easy application process. The reach of the Smart E-Lending program is limited to PGE and Pacific Power customers, and we recommend you reach out to your local bank or credit union to see if they are involved and seeing if your local bank or credit union offers a similar product if you're not within a PGE or Pacific Power territory. You can find out more at energytrust.org/financing. Now, before we look at some example budgets for solar and storage, we should recap the reasons why both solar and battery storage costs vary so widely. The cost of solar can depend on the size of the system, whether or not you're re-roofing, if you need to complete any structural analysis or structural reinforcement. And the cost of battery storage can depend on if you're installing solar and storage at the same time versus separately, how far you're installing it from the electric panel, if you're creating an essential loans panel, how many batteries you're installing, and lastly, applying to both solar and storage, the availability of incentives can affect cost. And for these reasons and more, it's impossible for me to quote the price of solar without having information about your site. With that being said, I am going to look at an example budget. So here's an example budget for an 8 kilowatt solar system, as well as an 8 kilowatt solar system paired with a 13.5 kilowatt hour storage system. So we can see the base cost for a solar system is $32,000, while for solar plus storage, it is $52,000. From there, you can then claim the maximum Energy Trust incentive, assuming you have worked with a solar trade ally, making the total out-of-pocket cost to you $29,500 or $44,500 if you're getting solar and storage. And just remember that those income qualified incentives can save you additional money, and you may be able to qualify for other incentives that we have not covered here today. So now with all this information, how can you get started? As I mentioned, besides offering incentives, Energy Trust of Oregon has a certification program for contractors to help ensure high quality workmanship. Energy Trust Trade Ally contractors are rigorously vetted, highly rated, and are the only contractors who can offer you the Energy Trust of Oregon solar plus storage incentives. We highly recommend working with a Trade Ally contractor and getting at least 3 quotes to compare if you're able. In fact, when you're ready to get quotes from the contractors, there's an extremely convenient and easy tool on the Energy Trust website that allows you to request free assessments from up to 3 highly rated contractors in your area. This online form takes only 3 to 5 minutes to complete and is a great way to make sure you're getting connected with Solar Trade Ally contractors that can best serve your solar and storage needs. You can also see it, you can scan the QR code on the screen and also see the link in the chat for more information. Once you've received selected your contractor, received quotes, and signed your contract, here's what you can expect regarding the installation process. Your contractor will handle all permitting, applying for the Energy Trust incentives, and designing your system. It's important to remember that they will need your signature on some of these documents, so the more organized you are, the smoother the process will be. Although system design can be quick, some jurisdictions have been experiencing permitting delays. Some counties have longer permitting times than others. For example, Multnomah County frequently experiences long delays, so they have been working on that quite a bit. Once it's time to break ground, installation is very quick. Most residential systems are installed within 1 or 4 days, making it a relatively painless process. Installation for solar is usually pretty quick, and it can take more time if you have a complex system design or if you're adding batteries. After the system is installed, your contractor will manage your permit inspections, coordinate the installation of your new bidirectional meter, and schedule your interconnection with the utility. This all can take 2 to 3 weeks, and after you've been interconnected, your system will be producing clean, renewable power from the sunlight falling on your property. And now with that, I'm here to answer your questions. If you have any, please put them into that Q&A box at the bottom of your screen. And if you're really excited after this presentation, you can also scan that QR code to get your 3 free quotes today. Those quotes are not binding, and they're just for you to get some great information. While I'm waiting for some questions to come in, I'm also going to go ahead and launch my final poll. This just lets me know how you think I did on this presentation and lets us get some survey about how we can do better. If there are no questions, I'm going to leave it open for another 30 seconds or so. And if there are no questions, we'll go ahead and end. But thank you so much, everyone, for being here today. We are extremely fortunate and hope you have a great rest of your evening. Thank you so much. We got one question. Someone said that they've been told it is cheaper and easier to install solar panel on metal roofs than a conventional one, and they're asking if I know why. And I do. This is a great question. So, standing seam metal roofs typically have ridges that are kind of like this, if you can imagine. So they'll be flat, and then there will be a small ridge, and then it'll be flat again, and the ridges come up like this. And rather, on a traditional roof, your solar panels act in order to mount them to your roof are actually punched through the roofing material and then welded in place using some special epoxy so that they are still weatherproof and that your no water or anything is leaking into your home. With metal roofs, however, instead of puncturing through them, a clamp is used. So it just clamps onto that little ridge like that and uses tension in order to hold your solar panels in place. Overall, this makes for a much simpler installation and makes the process go much quicker and helps save you money as just fewer materials are needed. There any other questions? Please feel free to put them in that Q&A box. I'll leave it open for another minute to see if there's any others. Well, thank you everyone for being here today. I hope everyone has a great rest of your evening and maybe you'll get some solar on your roof soon. Have a great night.